Just set up here. All right. All right. Cool. So, the world has never been as connected as it is right now. You literally have a computer in your pockets that can give you access to all knowledge that humanity has ever produced. You can talk to anyone alive on the planet right now if you want to. But at the same time, we've never been so disconnected. I was watching you right when you came in here. Like, how many of you have a laptop in front of you? How many of you were on your phones instead of talking to the person next to you? Technology was developed to connect us, but technology is dividing. And I recently read this book. There's a fantastic book by Jonathan Haidt, which is a social psychologist, right? And he's been really looking into the effect that technology is having, particularly on kids and teenagers, and the rewiring that that's doing to our brain. And he attributes the fact that technology creates certain kinds of interactions that are very different to the kinds of interactions that we have in the physical world. If you think about it, interaction through social media is disembodied, meaning we don't have our bodies in it. We're just abstract entities. It is asynchronous, meaning that you can post anything at any time and people will reply whenever they want. It's shallow because the moment that you feel maybe pushed too far, or maybe you feel when your thoughts are being challenged, you can just step away from it and let it go. And we don't have to deal with the challenges that we face. And it's solitary, because most of the time you're by yourself. In contrast, the interactions that we have in the physical world, the interactions that we have right now, they are embodied, they're synchronous, they're at the same time. Because we have our bodies, I can see your faces, I can see your reactions, I can see your facial expressions, non-verbal language. They're deep, because we can respond, I can monitor your non-verbal signals, I can react to that, I can adapt my talk depending on whether you are staring at me or you're staring at the computers in front of you. And they are collaborative, because we are no longer just by ourselves. We need to negotiate our actions. So this talk will be about how can we return to the physical world while still retaining some of the benefits of digital technology. This is not a Luddite talk that I'm going to say just turn off your phone, turn off your computers, even though you should turn off your computers. You don't need your computers right now, right? So you can just pay attention. Right? The stuff is being recorded, but the stuff that you have in front of you will be the same. But just think about it. Just the fact that this talk is being recorded means that a lot of the people that would have been here otherwise are not here. We are missing that physical connection. And Jonathan Haidt blames on exactly these characteristics the epidemic of mental health issues that we are seeing nowadays. So this talk is called Adaptive Interfaces for Mixed Reality Collaboration. What does that mean? It means interfaces that can adapt to the context in which the users that use those technologies are embedded. And they are explicitly designed for us to come together. Not just in the virtual world, but in the physical world. So if you're not going to pay attention to the rest of the talk, you're going to go back to whatever you're doing in your laptops, that's okay. This is my message today. We need to refocus our efforts in developing technology. So I'm assuming that if you're a part of SINCS, you are here developing tech, maybe? Well, we need to refocus our efforts in, rather than bringing users into the tech that we're developing, we need to do the other way around. We need to push tech out into the world so that we can reconnect with each other. Second, to do so, the approach that I'm going to discuss here is about mixed reality systems that can adapt to users' contexts so that we can meet in an embodied, synchronous, collaborative way in real time. And finally, we don't have to wait for the perfect hardware. We have hardware today that we can use to design the future that we actually want to live in, rather than what's possible today. So my name is Eduardo Velloso. I'm a professor of computer science here at the School of Computer Science, right up there. So my office is in the third floor of this building. And I just joined Sydney Uni. I spent my whole career at the University of Melbourne. Before that, I was in the UK, and my research is in human-computer interaction. So I developed interactive technologies, and my work has been mostly around interaction design for emerging tech, meaning how can we design interactive systems that don't look like computers? Anything from eye-based interfaces, mixed reality, virtual reality, physiological signals, and so on. So as I mentioned, this is the topic of today. How can we return to the physical while retaining the benefits of the digital? And this is not a new idea. When I was contemplating doing a PhD, I was very inspired by the vision of this guy who died, unfortunately, very, very early on. His name was Mark Weiser, and he wrote this very seminal paper, which everyone in HI should read, really. It's called The Computer for the 21st Century. And in this paper, he talked about this vision of what he called ubiquitous computing. And this is a quote from him. The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. So if you think about it, there are a lot of technologies that we don't think about as technologies anymore. Like the moment they turn on the light, just think about the technological infrastructure that is behind that power switch. But we don't think of that as, we don't think of that at all. We just turn on the switch. And that's what he sees as a profound technology. We don't think about that is just transparent in how we go about our days. We don't think of that as a digital entity. And he was writing this in the era of the mainframe, when we had just one massive computer with lots of users of the same computer. But he was witnessing this transition from this one-to-many to this one-to-one relationship between users and computers, which is the era of the personal computer. And he was thinking, okay, what's next? What's after the personal computer? Well, he envisioned this idea of the N-to-one relationship. So now instead of having multiple users per computer, now we have multiple computers for every user. And that's the vision of what he called ubiquitous computing. So computers wouldn't just be this massive thing in a really large room somewhere cooled down in the building, which every computer science department used to have. Computers would be embedded into our everyday objects. There might be a computer inside this bottle, there might be a computer inside this phone, there might be a computer inside this controller. And this is exactly what we have. This was his vision. So machines that fit the human environment, instead of forcing humans to enter that, will make a computer as refreshing as a walk in the woods. We wanted to put computing back in its place, to reposition it into the environmental background, to concentrate on human-to-human interfaces, and less on human-to-computer ones. Meaning, taking computer out of the box. Let's just put computers out there so that we can focus on each other again. And he developed a lot of technologies to enable that vision. So he created these active badges that would track you around the building, would know where you are. There were these tags that were like personal computers. They could write your notes. Think of a digital post-it note. There were the tabs, which were meant to be like pieces of paper that you could scribble on and leave somewhere. These would be scattered around an office, for example. And then there would be these active boards, which were like digital whiteboards that people could collaborate on. So you went from the individual all the way to the collaborative. And you might be looking at this and say, oh, this all rings a bell, right? So this is all stuff that we have nowadays. This is not some outlandish alien world. This is the world that we live in today. His vision came through. Now, the technological vision came through. But did his interaction design come through? Or the kinds of devices that he designed so that we could interact with each other again are actually drawing us so much into them that we miss this human connection. So did it put computing back in its place? Is it a walk in the woods like he imagined? Or did it just make things worse? Well, in his paper he also imagined a different kind of technology, where digital content would be put back into the world, and that is augmented reality. So virtual reality was certainly not within his vision, right? So that was the opposite of what Ubicon was. Virtual reality is about kind of just blocking out the physical world entirely. He wanted to put tech out of the world. And augmented reality was one way forward. So you might think, okay, The early technology in augmented reality was about mobile phone augmented reality. So you are taking a snapshot of the physical world, and you can render digital content that is registered to the physical world. Great, fantastic. So now, instead of focusing on some abstract virtual world, we're focusing on the physical world again, right? Great. Well, maybe not. Let me tell a story, and this is work done by my colleague Brandon Siam here, who back then was my PhD student. This was a field study that we did a few years ago of an installation so it's a museum installation. This was funded by Netflix, by the WWF, by who else? Google. Yeah. So this is in terms of in terms of funding for augmented reality installations, this is as high as it goes, right? So this is a really well-funded project. So this was a tie-in with David Attenborough's documentary on Netflix, Our Planet. And they built this installation that was designed to bring people together, to empathize with the problems that the environment is having. And the idea was that you walk around with a phone and you could see different environments, and as you walked around these environments, you were damaging those environments, and then in the next stage, you walk around again, reforesting those environments. Fantastic application. You had kind of these beautiful visuals, David Attenborough narrating, wonderful. This is what the usage of the application looks like. Lots of people walking around, all using their phones to interact with this content. That was registered to the physical world. Now, we did this in situ observation, tons of visitors, tons of interviews, 2 sites, both in the UK and Singapore. And Brandon, do you remember what we found?
People really focused on the technology.
Exactly. Technology that was designed explicitly to help us connect with ourselves and connect with the environment. All you saw in the end were people staring at their phones. Right? We saw this split attention between trying to just kind of understand the instructions and absorb the message, and instead of people talking to each other, we saw just attention turning into the content. And that represents a really a chasm into how we are designing technology. We've been designing technology so that we can put the physical into the digital inside our phones again. Instead, we need to reframe this. We need to think about how we can take the digital and push it out into the world. And this was a vision that, again, was around you. So back in the 90s, you had these guys that look super cool, the MIT cyborgs, and these were guys that had this vision and was thinking, okay, how can we do this in practice? And of course, if you look at the technology, was nowhere near actually something that you can use. They were building these prototypes in-house and trying to kind of, instead of staring at the phones, staring at the laptops, they were trying to keep computing at face level. And one of these guys, the one there on the rightmost side, is Thad Stannard, who you might recognize. He was the lead developer of the Google Glass project. And his vision for wearable computing was this ideal interface that would be with the user all the time, listening to the user's real-world interactions and updating appropriate files automatically. And he was still talking about files like that. Going even further, the computer should monitor the virtual world and notify the user as appropriate. So you had this idea of computers that are just with you. So you act as a normal human being. The computer is there in the background, monitoring what's happening and intervening whenever it's necessary. So see, it's a very different paradigm to what we're used to, where the computer is just sucking in our attention. Now, for this vision to be actionable, you need several ingredients. You need to put a lot of stuff into the stock plot. You need input. You need convenient ways for interacting with these machines. If you don't have a keyboard, you don't have the mouse, there's a reason why we love the keyboard and the mouse. It's extremely effective, right? The amount of throughput that you can get with keyboard and mouse is just amazing. You need output. You need displays that can render content in front of your eyes while still letting you see the physical world. You need ergonomics. You can't just have this massive helmet on you. You need a form factor that is appropriate to social context. You need processing. We can't talk about processing nowadays without talking about AI. The kinds of systems that Stan was talking about are agent-based systems. You have an agent in the background that is watching what's happening and intervening whenever it's necessary. You need battery life. You can't have a system that only lasts about an hour. And we're starting to see these ingredients come up. I mean, Brandon has used the Snap, what's the spectacles, right? Wonderful hardware. It lets see-through augmented reality. The battery lasts for
20 minutes.
yes, it's just ridiculous, right? You have the Meta Ray-Ban glasses. Have anyone used this? Yeah? Yeah, so great piece of hardware, great AI, no output, no input. Input based on touch, right? So you have the Meta Quest 3. You have a great ecosystem. Well, this is the Meta Quest Pro, actually. You have a great ecosystem of applications. Display resolution, meh. You still need controllers. Eye tracking in this one, meh. You have the Apple Vision Pro. Fantastic. Anyone tried the Apple Vision Pro? Yeah? What do you think of the display?
That's really crazy.
Really crazy, like really fantastic. Eye tracking spot on. Like I tried this not long ago, but what we need is kind of almost somewhere in the middle here. Right? So we actually want this form factor with this kind of input, with this app ecosystem, and maybe not video pass through. Maybe we want actually full see-through augmented reality. So the ingredients are there. They're just not together in the same package. You know, I was trying the Apple Vision Pro not too long ago. We got a month or two ago. That's Oliver. I don't know if you know Oliver. He is a good friend of the uni. He's always around. And it was funny because when I first saw the announcement of the Apple Vision Pro, as any academic, I'm a cynic, so I go like, whatever. But there was one thing in the announcement that I thought was quite funny, which was this.
For the first time, we've designed a fully three-dimensional interface, one magically controlled with just your eyes, hands, and voice.
Well, and Apple loves this, right? So they love to say that they were the first to do something, when in fact, even I was publishing on this topic 10 years ago. It's just ridiculous. So the point here is, the stuff that you're seeing out there today has been under development for the past 10 years. I was talking to a guy that worked in an R&D development lab at Sony, and he was saying it's about 8 to 15 years there for a product to go from R&D to market. So if you want to know what's coming, just go upstairs. You'll see. Now, the trick here is that we are using the tech of today to design the stuff that's coming up tomorrow. And I once, I know Thad Starner pretty well, and because he attended the same conferences that we do. And he says that his only constraint back when he was developing these technologies was the computing power needed to fit in a bag. So the bag that he's hiding there, that's where all the computing power would go. Right? But he was a guy that was designing the Google Glass 20 years ago. And it looks like that. Right? Could you actually deploy that? No, bloody way. Right? There's just no way that any reasonable, sane person would wear any of that. So even nowadays, he's the only one that wears Google Glass at conference. But still, I am terribly inspired by this idea of, you want to design you want the technology that we're going to use tomorrow, just design today, with whatever you've got right now. What matters is the ideas that you're trying to put forward. Now, so instead of thinking about, are the ingredients there? Can we actually build the tech that we want? Think about the other way around. What is the future that we want? What do we want from technology? We want technology that can augment our cognitive abilities. We want technology that can give us new physical skills. We want technology that can enable and foster physical, social connections instead of drawing us into just another laptop. So today I'm going to talk about 3 technical challenges that I'm worried about in enabling that data. So one is capturing users' cognitive, so what's inside their heads, in spatial context, what's outside. And then building intelligent mixed reality systems that look at this context and adapt the interface to match that context. And finally, if you have an agent that is making these adaptations, you need to trust that agent. Otherwise, nothing works. So why is trust necessary? And once again, I go back to Brandon's work. So Brandon, this guy, built this augmented reality system, a fantastic system. So it allowed you to take a bunch of data. So imagine that you've done a bunch of interviews, or you have some quantitative and structured data, all structured around Post-it notes. And you can bring the Post-it notes to different whiteboards, and you can cluster related ideas. And you have this agent that's monitoring everything that you do. This was a system built for the HoloLens, right? And as you start clustering data points, the system starts looking, hey, hang on, I think you are trying to get to something. You notice that the Post-its change color. And that's the system hinting you that, oh, you put these ideas together, maybe, you know, based on what you told me, I think these ideas are also related. So you see that the system is doing some initial clustering for you. In addition, the system is monitoring your gaze. It's monitoring your eyes, trying to infer that cognitive context, trying to infer what are you interested in, and highlighting the Post-it notes that relates to what you are interested in. And you see that some of those have green outline. And some other Post-it notes got collapsed. So that's the system telling you, look, based on what you're reading, based on what you're interacting with, I think that you'd be interested in this one. Don't bother with this one. This doesn't seem related to what you're interested in right now. Right? So the system has this proactive behavior. So just kind of trying to nudge you into focusing on what matters to you. Now, this was a murder mystery task, meaning that there were lots of clues, and you had to solve who was the murderer, what was the weapon, what else?
Time of the murder.
Time of the murder. And in the end, we compared three conditions. We compared one using the system, one using the mixed reality system without any agent helping you, and one just pen and paper. And this is what we found. Well, pen and paper was the most effective. Mixed reality alone, lower. Mixed reality plus the agent, huge variation. And then we started, hang on. These two systems are very, very similar. How come you have this huge variation here? And the answer was, well, there's two kinds of users. The users that trust the agent and say, okay, the agent is sending me this way, I'm going to go down that way. And they're the kind of user that would just go, oh, the agent collapsed this note. Nah, I want to see what's it. They go there and undo everything that the agent was doing. And those users underperform. So we have this kind of this bimodal distribution, which highlights some challenges for building these agents that are trying to help you, right? So even if the agent, so the performance-wise, the agent was tip-top, it was great. But users must trust it. Performance is not enough. Without trust, users just undo everything the agent is doing. So there's a lot of opportunities for future work. How can you get the user to convey what they want to do so that they trust the agent better? How can you offer feedback about what the agent is doing so that the user trusts them more? So the point here is that trust is not just about performance. Interaction design matters. What you tell the user actually has a huge impact. And I'll show you a study that we did that is just about that. So imagine that you're using the Meta Ray-Ban glasses. And I don't know if you know this, it has a camera, so you can say, okay, Meta, what is this? And the agent will tell you what it is using computer vision. So imagine the user goes there and asks, looks at a plant, a flower, and says, well, what is this flower? And nowadays we have plenty of systems that do this. This is API stuff. Like this is not research grade. Apple does it, Google does it. You just show a photo, it tells you what it is. Right, great. Now imagine that you have this headset on you, and you go there and say, okay, what is this? Dog, great. What is this? Cat, great. What is this? Ptarmigan. Now, would you trust the agent? Would you believe there's a ptarmigan? Who would? Yeah? Okay. A lot of you. Okay. But what if the agent had gotten the first ones wrong? What if instead of saying this is a dog, it's like this is a cat. And when it's a cat, you say this is a dog. And then it shows you a bird, you say this is a ptarmigan. You say, it's a ptarmigan. That isn't. That's a say, oh, I mean, but it got the dog and the cat wrong, so it's definitely the ptarmigan. So the point here is that a lot of the tasks that matter to us are of complementary expertise. Sometimes you know the answer, sometimes you don't. And you use the information that you get in the tasks that you know the answer to calibrate your trust. In the tasks that you don't know, that's when trust is needed. Right? So when you know the answer, you see that the agent's getting everything right, and then you don't know, okay, I guess I will follow. Right? But if you don't trust, then, well, you're stuffed. And this is exactly the experiment that we ran. So we showed participants, we built a fake AI that would, so if you're from New Zealand, you know that this is correct. But if you're not, that depends on how much you trust the AI. And this was the experiment design. So we had interweaved tasks that the participant knew the right answer and tasks that there was no way that they knew the right answer. And we would calibrate the accuracy of the AI. So in the first phase, the AI was really accurate, and then it drops the accuracy of the AI. And then in the third phase, we brought it all the way back up. Right? And we collected trust measures at each step. Now, what do you think happens with trust here? High or low? High. What do you think here? What do you think here? That's what we want, right? Isn't it? Like that's the interesting thing. So, okay, trust here, you'd expect to be high, then it drops, and what happens when performance goes back up? Well, the interesting thing is what we do here in the middle, because we can try to do something about it, right? We can say, okay, we can do nothing. We could apologize, say, oh, hey, I'm sorry, I know this is not shit, so I do apologize. We could deny it, say, hey, I noticed that you're not following my advice and you're undoing everything that I'm doing. Piss off. I'm right. Trust me. You could say, look, yeah, I know that I've been screwed up. I promise to do better. Or you could say, look, forget about what just happened. There's a new model that's powering me. Trust me, things will be better from now. Right. This is what happens when you don't do anything. So trust is high, trust is low. The final trust is somewhere in between. So that's the effect of performance alone. If you apologize, it goes back to where it started. That is amazing. This is like the effect of, I'm sorry. If you deny, it's nothing. Like it's just, okay, nah. If you promise to do better, you might as well not have done it. But if you say there was a model update, off you go. So if you give a reason for an improvement, they trust you more than they trusted you before. That is incredible. These effects that you're seeing here, the performance is exactly the same. This is purely interaction design. So performance recovery is not enough to repair trust. Now, I'm talking about all this, but how can intelligent mixed reality systems adapt to users' content? We're talking about after the adaptation, how can users trust it? How can they adapt? So imagine this scenario, where you're at home, you have a VR, mixed reality headset, you set up your virtual office, you have your desk, you have a lamp here, you put all your virtual screens, brilliant. And then you go to a cafe, right? You bring up a VR headset. Where should these widgets go? You don't have that lamp anymore, you don't have your bottle, you don't have your window, everything is different. How can they adapt to the layouts they developed at home for a new context? So should the system just do nothing, preserve the layouts? Same thing. Should the system prevent occlusion so that you can maybe see the context behind it? Should it match semantic relationships? Maybe you have a calendar that you want to near a clock, so you want this clock there in the new environment, so maybe you want the calendar there instead. Maybe you should snap to surfaces. There's a wall, so I want my calendar to be affixed to the wall. Maybe often used widgets should be closer to the user. All of these are reasonable. Or maybe all of these. So maybe you're looking at this, if you have experience with optimization, you might look at, hang on, this is just a knapsack problem. Right? So just, okay, there's different things that people value. You come up with some weighted average of these and use that to solve the problem. Right. So yeah, you're right. That is the answer. Right? So you can do layout optimization. We can build a utility function that, given a certain layout, spits out a value for the layout. And then use an optimizer. These are ready-made software. They can just plug it in and it will run for you and give you back an answer. And then render the interface and boom, pop the champagne. Great. Problem solved. And if you look at the literature, indeed, there are people that do exactly that. And in this particular paper, for example, you see this equation there and there, which is the utility function. So just maximize this utility function. We have a bunch of features of layouts, and just multiply them by a weight, and the weight is the relative importance of each feature. And then you read something else there and say, okay, we empirically determine the weights. There you go. Equal weights roughly for everything. And then, I read that and I was like, this doesn't sound quite right. It can't be that everything has equal weight, or it's like, this is looking too good for my taste. And they'll say, we're thinking like, okay, what is the relative weight? So if I ask you, what do you care about when setting up these layouts? You're not going to be able to answer me. I don't. These are latent features in our brain. Introspection is not enough to reveal our preferences. So we looked at, how do market researchers do this? And essentially what they do to find out how much you care if you're buying a TV. Imagine they have two TVs. They have different prices, different resolutions, different features, blah, blah, blah. And you have a basket of features, and you're going to make a comparison, and you're going to buy one of those. Now, market researchers are able to use this to calculate the relative importance they put on each feature of the TV, to find out how much you're actually willing to pay for it. We did exactly this. So instead of asking users to tell us what they care about, show us. So the point here is that if we know the weights, great, we can come up with a utility function, and based on the utility function, we can generate a layout. And great, if we have the utility function, we can generate the layout. If we have the weights, we can generate the utility function. But we don't have the weights. What do? Well, not a problem. Just try out lots of possible weights, find out which ones people prefer when you compare. So if I generate a layout with these weights, and generate a layout with different weights, and show you both, well, whichever one you pick, it's going to be the right. And if you do this lots and lots of times, you can actually converge to the right weights. And this is exactly what we did. So we did a crowdsourced study, put it up online, hundreds and hundreds of participants choosing between different layouts. And it looked something like this. We had lots of different contexts, but it was all kind of virtual. And got lots of layouts like this that were generated with different weights, and got people to use the slider to tell us which one they preferred. And what comes out of that is the relative importance of these things. So what we see from that is that users care a lot about consistency with the initial layout. So they don't want a completely new layout when they change context. And they want a compact layout. They want layouts that are kind of within arm's reach. They don't care at all about semantic association. So that idea of putting a calendar next to a clock, which was the whole point of that paper that I just showed you. So there you go. Now, all of this is about you adapting your layout to the physical context around you. But I started this talk talking about how we need to connect to each other. What about multiple? Well, think about this. Imagine we were meeting in VR. Metaverse, blah, blah, blah. I have my VR headset, Alice has hers, Bob has his. We meet in the metaverse. Great. There's no connection to the physical environment whatsoever. All you need is to empty out enough space around you, off you go. Great. But now, this is what we want. Right? So we still want to be grounded in the physical world. Because, you see, the metaverse is there. The technology is right there. And still people are not using it. Because we need physicality. Physicality is absolutely necessary. So I don't believe in the metaverse. I believe in mixed reality. I believe in bringing the virtual into the physical. Now, imagine this situation. You have a guy here wearing his HoloLens, and he's seeing a hologram of his collaborators. And look, it's great for him. We can see he's in his home, you can see his collaborator, but what is the experience like for her? Because she is somewhere else as well. And in these videos that you see of people collaborating in mixed reality, you never see the other side. Right? She must be wearing a headset too, but where is it? I don't know. The point of this is that distributed collaboration in mixed reality not only requires you to adapt the virtual to your physical, it also requires you to adapt the virtual to their physical, which automatically binds your physical to their physical. And this is what we call blended reality. Because it's not just about mixing the virtual and the physical. It is about mixing the physical with the physical. My physical with your physical. So what are blended realities? So mixed reality experiences in which the physical space around one user is matched to the physical space of another user through a virtual medium. So we have VR, which is virtual only. We have mixed reality, which is your physical plus the virtual. And you have blended realities, which is my physical with your physical with the virtual. So instead of having just Alice and Bob in VR, we actually have Alice, Bob, and their respective physical environments. And these need to match. The problem is, they will not match. So what do? Well, first challenge is this. Spatial heterogeneity. If my room is different to your room, how can we reconcile it? Second challenge is, if we, right now, it's fine. We have a big room, everybody's here. What if in my office? If I'm in my office, maybe fits 3 or 4 people. How can I get you all inside my office if we're having this meeting? How can we support? So asynchronous collaboration sucks. I hate it. But it's required. We live in Australia. We are asynchronous with the rest of the world. It's a reality. Right? So how can we create experiences that make us feel like we are there? How can we enable these asynchronous meetings that people still feel like they can contribute meaningfully? And that is Marvin's PhD topic. And finally, how can we create these experiences in a way that preserves what we like about physical face-to-face interaction? How can we preserve proxemics? Proxemics is how we organize ourselves into groups. So if I'm standing here looking at you, that's a proxemic setting that tells you that I'm talking to them. If I was facing back to them, you know that I'm not talking to them. Right? All of these nonverbal behavior, meaning I'm looking at you and I smile when you say something, and I say, all of this is a lot of rich information that we need to be able to interact with each other. So here's an example of heterogeneity in space. So imagine that we are working across a desk and a whiteboard. This is my setup, and this is the collaborator setup. Right? So we both have a desk, we both have a whiteboard, but we want to collaborate in mixed reality. So we could align our spaces around the desks, like that image there, where I go to my desk, you go to your desk, great, we're around this virtual desk. But now we need to go to the whiteboard. So the moment that I go to my whiteboard, you go to your whiteboard, I see your avatar going in a completely different direction. So we need to realign. So we could realign a line around the whiteboard. So now we can collaborate on the whiteboard. Great. And this is an idea that we explored in a paper. And I'll let my colleague Jens Emil Grunbeck explain this is what we call partially blended realities, because instead of trying to blend the whole environment, we just blend around things that matter to us.
So how do users transition between tables and whiteboards? We demonstrate 2 different techniques to do so. Via the realignment technique, users can trigger a button that switches from aligning around the table to aligning around the whiteboard. With the overlay technique, all partial alignments are overlaid at once, and Alice sees Bob twice as an avatar located relative to each partial alignment.
So maybe that was quick, but in the overlay technique, you basically have 2 representations of this. One aligned on the whiteboard, one aligned at the desk, and then your collaborator can interact with whichever avatar is most convenient, depending on the interaction. Right? And of course, that's not the end of it. Like we could, in this work, we're triggering this manually. But you can think about ways of doing this seamlessly. If right now I'm at the table, maybe I'll go to the whiteboard, and then the space realigns. But it can be quite jarring to do this automatically. So how can it do this in a seamless way? Or maybe instead of realigning the environments, maybe you can warp the environments. Maybe you can create these non-linear transformations that make this even more seamless. But the point here is that, why isn't it? Because we need physicality. We love the reconfigurability of Miro and all other virtual whiteboards. We love the fact that we can, take a bunch of post-it notes, we can select them all, throw them over there, we can copy them, duplicate. This is great. but we love the physicality of being around the physical whiteboard. So how can we bring the best of both worlds? Bring the social, kind of the non-verbal communication that we have around, as in when you try to collaborate on Miro, like we lack this kind of, it happens to me all the time that I'm looking at something and then you're like, oh, no, but you're looking at the wrong area. Because we lack this non-verbal behavior. This doesn't happen in a face-to-face setting. So how can we bring the best of both worlds? I'll show you now a paper that we are presenting next week at CHI, which is our biggest conference, where we try to kind of reconcile some of these tensions.
To address this tension, we introduced Blended Whiteboard. Blended Whiteboard supports a unique collaboration style where users can interact with the physical whiteboard while together as virtual avatars. They can also reconfigure the blended space by changing the avatar orientation and spacing, or panning and zooming the whiteboard content, all without losing the physical frame of reference. Users interact with the system by sketching with the stylus, changing avatar formations via a hand menu, and navigating the whiteboard content via gestures. To combine physical and virtual whiteboard capabilities in a single system, Blended Whiteboard implements 3 core design principles. The first principle is to support dynamic whiteboarding by providing multiple facing formations. With Blended Whiteboard, Alice and Bob can brainstorm while next to each other with easy attention switching between person and task. But they can also switch from working side by side to working through the whiteboard. When in front of each other, it's easier to work on the same sketch and monitor each other's actions. The second principle is that content can be navigated through either shared or individual control. Alice and Bob's local surfaces work as physical viewports into an infinite canvas. When they cooperate closely, Alice and Bob can pan the canvas and see changes synchronized across views. But when they work independently, they should be able to navigate individually. To do so, Alice can pan her viewport. This does not affect Bob's content view, but instead increases distance between their avatars, allowing them to work on independent surfaces. The third principle is that surfaces can be reconfigured, but also easily reversed to the original configuration. While they work independently, Alice can zoom in her viewport on details of the content. Instead of disrupting Bob's view, it changes the relative scaling of avatars. These scale disparities can provide awareness cues, like showing Bob that Alice is working on a detail, but they also compromise the physicality needed for natural conversation. To resolve this tension, users can tap to join their partner's viewport. This interaction enables Alice and Bob to snap back to reality with physically aligned whiteboards and avatars at eye level.
So, I showed you a lot of different systems here, showed a lot of different studies. So what can we take from all this? Well, first is that we need to refocus. So we've been doing things in a weird way. I don't think the way that we're developing technologies nowadays is leading us the right way. We need to refocus the mission. We need to think in terms of how can we actually augment human cognition? How can we give people new physical skills? How can we bring people together without people? And you can begin to design for this future right now. The technology is there. It might not look like what you have in your head, but that's not a problem. We can do it right now. And future mixed reality interfaces, the kinds of interfaces that I'm interested in building, are the ones that adapt to what's in people's heads, to what's outside people's heads, and foster trust in order to be effective. Otherwise, it's all wasted. And when we add other people to the mix, when we bring in that social layer, every challenge they had before becomes amplified. Things become much harder, but much more exciting. We have to blend not just the virtual and the physical, but the physical with the physical. So if you're interested in exploring this, join us. We are building a brand new lab starting next semester.